The freedom of flight is only possible with careful attention to your aircraft. No matter where you're headed, get there safely with proper maintenance and regular inspections. Safety is paramount at Hartzell Aviation, where we build reliable products and power general aviation into the future. And we're growing, so let us introduce you to our family of brands. Hartzell Aviation's flagship is Hartzell Propeller, headquartered in Piqua, Ohio. Hartzell Propeller is the global leader in advanced aircraft propeller design and manufacturing technology for general aviation. Hartzell Service Center is where we provide aircraft propeller overhaul and repair. Hartzell Engine Tech is our leading OEM supplier and aerospace technology company. At Hartzell Aerospace Welding, you'll find aviation exhaust systems and custom metal fabrication. Quality Aircraft Accessories, or QAA, is Hartzell's Part 145 Class 1 and Class 2 repair station, with the in-house ability to overhaul most engine and airframe accessories. Today, we'll tap into expertise found across each of the Hartzell Aviation brands. Led by Hartzell Engine Tech's Director of Product and Technical Support, Alan Buffkin, we'll get maintenance and inspection guidance straight from the manufacturer.
Here we have a Vans RV8. Vans aircraft is one of the world's most popular experimental home-built aircraft. In my hand, I have the pre-flight checklist for the Vans RV8. Specifically on the Vans pre-flight checklist, the only item that's encompassed in the Hartzell Aviation product lineup is the propeller. Vans simply states, check for security and gouges. But let's take that a step further. We are going to look for nicks and gouges and cracks. We're also going to look for debonding. This particular propeller only has an abrasion strip. There is no de-ice. We want to check that to make sure it's not damaged. There's no major nicks or scratches or any damage to that abrasion strip. You also want to check the blade for any type of radial play. Working our way up the blade as well, we're going to check for general security and clearance of the hub assembly from the propeller spinner on the shank. We also want to look for any grease or oil which might be protruding. We'll check all three blades in that manner. We'll check the spinner as well for any nicks, dings, or cracks. Also the security of the hardware all the way around. But let's dig a little bit deeper in this propeller. Let's uncowl, get everything cleaned up, take the spinner off, and look at this propeller from an oil change or even possibly a condition inspection standpoint. And here to give us a more in-depth description of our composite Hartzell 3-blade propeller is our subject matter expert from Hartzell Propeller, Jareth Woody. Jareth, good to see you.
Hey, good to be here, Al.
Tell me some more about yourself.
I have a background in aviation of about 12 years now, encompassing military, GA, and commercial aviation. I'm a certified A&P mechanic and a licensed private pilot.
Well, when it comes to our 3-blade composite propeller here, what can you tell me more about our condition inspection we should be looking deeper in?
We actually recommend that even though this is an experimental aircraft, and depending on the application installed on the experimental aircraft, we treat each one of our propellers as though they're a type certificated propeller, in which we'd like you to follow the recommended TBO conditions as posted in our service letter 61Y. So the general visual inspection of the propeller during the pre-flight inspection can reveal several things. We're looking for nicks, gouges, and scratches to the paint, or any damage to the erosion shield, or crushing to the trail edge of the propeller. If found during a pre-flight inspection that a lightning strike has occurred, you would find that a brown residue or soot area is discovered. Typically, this occurs at the tip of the blade and goes inboard, possibly arcing to some of the internal components, such as the hub or cylinder or even bulkhead, if installed the ice protection system. Depending on the blade type, we want to make sure that if it's applicable to the blade, that the erosion tape is installed on this propeller blade. As we're keeping to those TBO limits, certain conditions that we're looking for are any oil or leak coming from this propeller assembly. Also, while we have the spinner off and the cowling off, we can look at the actual mounting in the back of the propeller along the flange. The bolts should be tight, fastened, and safety. While we have the spinner off, we can also look at the hardware itself. We're looking for any cracks that may be propagating from any of the nuts or bolts, corrosion on the hardware, and also if anything's missing or loose. The actual tap test, since we have a composite blade, is not to exceed 1,200 hours. That's on any surface area, such as the camber or face. The nickel erosion shield's actually not to exceed any 600 hours, or lining up with any scheduled maintenance that may be performed. The radial play on the composite propeller is actually something termed preload. We want the blades to be taut. So what we're looking for is an in or out play, a fore or aft, or an end play. The blades should return back to their normal position without any effort.
Now, for my interpretation, we have some stickers here identifying the lubricating greases, and this is a new lubricating grease that's in here?
That's correct. So this lubrication is actually placarded with a Nyco GN3058. So in 2020, we actually started using this in our aftermarket propellers at our assembly coming out of the factory, but shouldn't be mixed with an aeroshell mineral-based grease. So here's some examples that you might find during your pre-flight inspection or your routine maintenance on a composite blade. Along the trail edge, we've got some chipped paint. The chipped paint goes no deeper than just the paint itself and actually does not go into the composite material. Here in the center of the blade, we have a gouge, but a full assessment would be needed in order to determine the actual depth of that gouge. Additionally, along the leading edge, we have another gouge. We want to use our evaluation skills and the applicable field maintenance manuals, owner's manuals, and personnel who may be certified to work on a propeller. Also keep in mind, some of these damages shown here are actually airworthy. Let's talk about the proper lubrication for this hub here. So we've recommended with any lightweight or compact propeller that we don't add any more than 1 fluid ounce or until it actually comes out the other side. Here we've got a fitting and a Zerk fitting on the engine side of the hub. This is to prevent any over-greasing condition that may occur in the cylinder and actually make the blades sluggish during flight.
Jareth, I want to thank you for sharing your technical expertise with us today. I hope to see you again in the future. On this Lycoming IO360, you'll notice not only the SkyTech starter, but the ring gear assembly. The ring gear assembly serves 2 purposes. It is also the start ring for the starter, also carries the alternator pulley belt in the V-groove on the back side. In this particular instance, I don't know what pitch this ring gear is. You can always simply count the teeth to determine the number of pitch, which are 2, 122 and 149. In this instance, I have my SkyTech ring gear gauge. I'll take this gauge, I will go on, I will notice that 122 doesn't fit, but 149 fits in the gear. That tells me that I know that this is a 12-volt aircraft, that this is a 149-12 LS starter by SkyTech. When it comes to Lycoming starters, there are several models that you can find. In this particular case, because we have the airbox in the configuration, we use the LS with a side solenoid combination because it fits the application best. Most Lycoming starters by SkyTech will fit most applications. However, some applications due to airboxes, STC bracketing, air conditioners, or oil coolers might not fit the engine due to that being installed. On starter itself, we want to check the general condition of the starter. We want to check all the leads for torque to make sure they're securely fastened. We also want to check the starter where it's connected to the engine mounting bolts. Make sure for general security that they are all torqued. Lycoming starters also, because of kickback, can be prone to some type of damage. Most starters you find will either have shear pin or kickback clutch assembly. Some may have none. In this particular case as well, you want to inspect the housing for cracks around the inside for kickback damage. Kickbacks can be so fast and severe, regardless of the protection that's in there, it can still damage the starter. If you've had a severe kickback, you need to inspect that starter. Moving back from the SkyTech starter, we also have an alternator assembly. The alternator assembly depends on the ring gear too from the backside where our belt is. On an alternator system, we want to inspect not just the pulley ring gear of the alternator, but also the ring gear of the engine. We want to check that for general condition and the belt as well. We're also looking for belt tension, pulley condition of alternator, and the alternator's hardware of attachment as far as brackets, arms. We want to make sure that they're free of cracks and the hardware is secure. Typically on experimental aircraft, you'll find 2 types of alternators. You'll find an internally regulated, but you can find externally regulated as well. Internally regulated typically have Molex type plugs, which will plug into the back. If you have that type, you want to check the condition of the plugs and the wires as well. For any type of chafing, If you have external, you want to make sure the general condition of your terminals is in good shape, that everything is torqued down, and that no wire chafing occurs as well. We suggest when it comes to battery types on these aircraft that you stick to a good non-lead acid battery or a good lithium ion battery, but in particular for the lithium ion, some type of battery management system, whether it be internal to the battery or external. A lithium battery without a battery management system can damage your alternator. Now that we've discussed that, let's move back to the magnetos and the ignition harness. On this aircraft, it's equipped with 2 magnetos for this IO360. You want to check the general condition of the magneto. You also want to check and make sure where it's attached to the engine, that it's torqued, good condition, no leakage. Also, you want to check the grounds of the magneto as well as the input attachments. You also want to check the lead attachments at the end of the alternator. You want to check the alternator to make sure it's in good condition. You also want to check the grounds and the ignition hot leads. Good condition, no chafing on wires, everything's torqued. You'll also check the ignition harness. At the end of the magneto, check the condition of the harness, make sure it's secure all the way down. You'll want to follow that harness, noting any chafing, burning, or pinching of that harness all the way forward for the top of the cylinders and the bottom of the cylinder to the spark plug. You'll want to repeat this process for the other side of the aircraft as well. Now that we've had a chance to look at the magnetos, we'll find ourselves at the engine mount and below it, the exhaust system. Let's take this opportunity to bring in our subject matter expert on these 2 items. I would like to introduce you to Mr. Tom Hyde of Hartzell Aerospace Welding. Tom, good to see you today.
Alan, good to see you. It's a pleasure being here.
Can you tell me more about yourself and your experience?
Prior to joining Hartzell Aviation, I was one of the original owners for 27 years at Aerospace Welding based in Eagan, Minnesota. I'm also been an A&P mechanic for 40 years, and I recently earned my private pilot certificate.
Well, Tom, let me tell you more about where I'm at here. I've just finished the accessories, made my way back to the firewall. I'm up to the engine mount and exhaust system, and I understand that you know a thing or two about that.
Yeah, I can go over the engine mount a little bit, and then after that, we'll go through the exhaust system.
Why don't we start with the engine mount?
Well, all engine mounts are made out of 4130 chromoly steel, so you got to keep in mind for corrosion. Now, the 4 main things that we're going to be looking at here today, doing any inspection, whether it's during an oil change or the condition inspection, we want to look for cracks, we want to look for chafe marks, we want to look for any bent tubes, and we want to look for any missing paint. As I mentioned earlier, the frame is made out of 4130 chromoly, which is a mild steel. If any of the paint is burnt off or rubbed off or missing, there will, over time, become corrosion on that surface area. So it's really important to keep up the paint and make sure the tubes are covered with the coating of good paint. We want to look over the engine mount frame here at the firewall, at the engine isolators, and anywhere where there's a weld joint. Anywhere where 2 tubes come together, anywhere where there's a gusset welded in, those areas can be prone to cracking. We just want to do a general visual, make sure we don't see any cracks in those areas. We, of course, also want to look over all the tubes for any bent tubes that might have come from a hard landing or any other type of undue stress on the engine mount. We want to look over the isolators here attached to the engine. We want to look them over to make sure they're not dry and brittle or cracked. Over time, they can age. We also want to look at the hardware at the engine isolator, as well as the firewall when it attaches to the firewall to make sure our hardware is intact, it's torqued correctly, so everything is sound and not loose. We also want to look at the firewall where the engine is attached and make sure there's no buckling or wrinkling in that area, which again could have been caused by some type of hard landing. Of course, the stresses on the engine mount can be a little bit different depending on whether it's a tailwheel or a nose wheel aircraft. Next, we want to look for chafe marks. We want to look the entire mount over anywhere. As you can see, there's lots of things here in the engine compartment, and many of them are fastened or tied off to the engine mount. We've got braided lines, we've got wire bundles, we've got cables, we've got oil lines, we've got fuel lines, all throughout the engine compartment, and many of those run really close to the engine mount. And so it's really important to make sure they're secured correctly by an ADAL clamp. These are aviation clamps that hold these wire bundles or cables or fuel lines to the engine mount. and secure them there. It's important that you look at the rubber and make sure that rubber is intact, that it's not dry, cracked, or missing, because if it is, the wire band that's here as part of the clamp will start to chafe into the engine mount tube. We also don't want to use zip ties directly to the engine mount tube. We want to make sure, as this operator did, correctly put a rubber blanket of some sort, some kind of rubberized material underneath the zip tie between it and the engine mount. There's also, just like the ADEL clamp, it's important to inspect that area, make sure that's there, not intact, and it hasn't wore through. If you zip tie directly to the tube, it also can move over time and chafe into the engine mount tube. And here I've got an example of one of those kinds of tubes. You can see it's a very light chafe mark there, but keep in mind, these tubes are only 49 thousandths thick on the wall thickness, and therefore the inspection criteria on these tubes typically is 10% of the wall thickness, which these are only 49 thousandths thick. So if you get a 5 thousandths deep chafe mark there, that would be cause for concern or reason to remove the engine mount from service and have it repaired. Next, I'm going to talk to you about, go back to talking about the isolator and the isolator pads. You can see here we've got a crack in what was an isolator pad. Even where the engine isolator is, it's meant to dampen the vibrations from the engine, but even there, you can start to get cracks in those mounts. So pay particular attention to the isolator area for cracks. Also, earlier we talked about the paint. I mean, it's very, very important to have the paint on the mount. Here you can see what happens to a tube. 4130, again, is basically steel. You can see the corrosion that has started because there was paint missing from this area, all the way to the point where it ate a hole right through the tube. So if you see any kind of blistering or rough area on the tube, they should be nice and smooth and shiny. And if any of the paint's missing or you feel them and they're a little rough, that could be corrosion starting underneath the paint. Now on the exhaust system, just like the engine mount, there are certain things we want to be looking for. Cracks, chafing, making sure the exhaust tubes are routed correctly, make sure there's no heat distortion of the metal over time due to excess heat. So we want to look at the exhaust flange where it mounts to the cylinder and see that there isn't any cracks there. That can be a highly stressed area because of the engine movements. We want to follow all of the tubes down, look for any chafing. And this particular system does not have a muffler. It's a straight crossover system, which joins underneath the engine. You can see there are some flexible ball joints in this system. It's important that those ball joints are free and moving. Now, when they're installed here, you really can't flex them and move them. But if you ever have the exhaust system off the aircraft, it's important to try and move the components separately and make sure that ball joint is moving. You also see here we have a bracket which joins this pipe to this pipe. We want to make sure that that hardware is intact, it's torqued and tight. We also want to make sure that there's no cracks in this area. Now, something that might help you determine or see cracks also is wherever you might have a crack, you might have a minor amount of yellow or white stainage, and that's normal, as long as it isn't excessive. If you do see excessive amount of stainage, you might want to look deeper and find out what is causing the leak. Whenever you have the exhaust system apart, it's a good idea to put a high temp anti-seize on the two components before you put them back together. Keep in mind, the exhaust system operates at 1400 to 1600 degrees F. So make sure you have a high enough anti-seize rated temperature in order to withstand those kind of temperatures. Working back on the exhaust here, we also want to grab hold of our tailpipes, make sure the tailpipe hangers are in place, make sure they're solid and not loose, make sure all the bracketry and hardware is connected, and just make sure they're sound. You can do that during a pre-flight inspection, oil change, or a condition inspection at any time. Next, we want to talk about cabin heat. Now, all exhaust systems on single-engine airplanes provide cabin heat to the cockpit. So this is another area in which we really want to talk about safety, because if we have any kind of cracks, openings within our exhaust system in the heater area, we are going to pump carbon monoxide into the cockpit. If you're doing a condition inspection, it's always a good idea to remove the cabin heat shroud, inspect the shroud for any chafing and cracks, and look over the area that you're collecting the heat from and make sure there's no cracks, holes, bulges, or any other deformities in that area. It's always good to have a good carbon monoxide detector inside the cockpit. Now, there are very inexpensive small spot detectors that you can buy for a few dollars and have in the cockpit, which will chemically change if carbon monoxide comes into the cockpit. Or you can buy an electronic carbon monoxide detector, and there are several on the market. They're fairly inexpensive, but is a big safety concern about an exhaust system is carbon monoxide being released going into the cockpit, which could incapacitate the pilot and the crew.
Inexpensive investment for peace of mind.
Yes, you're correct. Now, for those exhaust systems, like we have here, a straight stack system simply collects it from the exhaust stack, the heat for the cockpit. Other exhaust systems may have a muffler installed, like I have here. This is a heat exchanger muffler, which also has a cabin heat shroud wrapped around it. The air comes into the shroud, collects the hot heat that's inside the chamber, and takes it to the cockpit, just like you see here on this shroud. Now again, during a condition inspection, we want to take the muffler off, take the shroud off, do a complete inspection of the heat exchanger area, make sure there's no bulges, cracks, or holes in it, once again for carbon monoxide reasons. Another thing on a muffler, most of them have an engine baffle inside them. You want to look inside the muffler whenever you have it out of the engine compartment. Look at the condition of the baffle. As you can see on this one, it's become heat distorted and lodged in the tailpipe outlet, which can be another safety hazard, which would cause your engine to lose power because it wouldn't be able to breathe and the exhaust gas would not be able to escape. So make sure we pay attention to the baffle inside, any mufflers you might have installed in your exhaust system, as well as the heat chamber.
I know this is particularly a fuel-injected engine, but what about for regularly aspirated engines? Is there any other considerations?
Like our cabin heater, we have a secondary shroud that can also be installed on one of the exhaust stacks to collect heat from the exhaust to provide carb heat into the carburetor when it is needed. Now, we want to take a look at these shrouds, make sure they're installed correctly, make sure they're not cracked or chafed, make sure they're not loose and rattling. But when we're doing a condition inspection, you might want to remove the shroud once again and look at the exhaust component that is collecting the heat for carb heat. As you can see on this one, it is very heat distorted. Now, keep in mind, this is a chamber collecting the heat. This pipe gets very, very heat soaked and hot at times. Look the shroud over. Again, like I said, make sure there's no heat distress to it, any cracks or anything of that nature. And when you reinstall it, make sure you get the screws nice and tight so it's very secure so it isn't rattling around on the exhaust stack. Now, where does the heat go for carb heat? Well, that's where we get into our carburetor air box here. If you have a carbureted engine, this is your mounted on the bottom of the carburetor at this flange area. Now again, on your carb heat box, it's really important to just simply look it over for any kind of cracks, chafe marks. Make sure your control cable is secure in place. Make sure it's routed correctly so it's free and moving. You want to look for cracks at this base flange where it mounts to the bottom of the carburetor. This is where a lot of cracks develop, and this flange is riveted inside to the body. As you can see on this one, someone has put some RTV on it. Now that would indicate to me that somewhere there was a crack along the line and they were simply putting the RTV on to cover up the air leakage in that area. Well, that's not really a recommended type of field repair, because as you can see, these flanges can completely break and come separated from the box. Now, another type of field repair that we also don't want to see in these boxes that can also be hazardous is replacing the rivets to do a field repair with some type of screw, nut, or bolt like we see here. The problem you find whenever you have loose rivets or you put these type of screws in here, they can come loose through vibration over time and go up through the carburetor and into your engine as FOD, and that would be very damaging to your engine. So make sure we look the carb air box over for any kind of cracks or chafing or wear. Also, when you have the air box off, you may want to make sure the door actuates, make sure the bearings are intact, that they aren't worn or elongated. Make sure your flapper inside the air box is intact and not torn. And also make sure the seal between here and the air filter as the air comes in, that the seal is not torn or worn as well. If any of those are worn or missing, make sure you replace and repair the box appropriately. So that kind of completes the exhaust system, the engine mount, as well as carb heat.
Well, Tom, I'd like to really thank you for your time today and that informative description of both the engine mount and the exhaust system. Thank you so much.
Alan, it was a pleasure being here. Thank you.
We hope you've enjoyed our video on our Vans RV8 today. I'd like to thank our subject matter experts for participating in the video. At Hartzell Aviation, we're dedicated to providing aviation products and services that deliver uncompromising quality, performance, and support. If you would like to learn more or contact us directly, please visit us at hartzellaviation.com.